Hello everyone, in this video I will be running through a new concept for you. But before I start the video, I'm going to share something that happened last week. Last week I accidentally dropped a porcelain bowl, and in a frantic bid to pick up all the pieces, I accidentally cut myself. And then I started to bleed. But if you realize after a while your bleeding will stop naturally. That's the focus of today's lesson. We're going to be looking at a process called hemostasis. Hemo meaning blood, and stasis meaning to stop. And there will be three parts to this lesson. We're going to look at three hemostatic processes that aid in bleeding to stop. The first part of how bleeding stops is through this process called vascular spasm. Vascular meaning that it takes place at the blood vessels, and spasm indicates that there is an involuntary contraction of muscles. Here in the diagram A, you see that there is a blood vessel, but you see that there is a damaged part of the blood vessel. The blood vessel walls has been broken, and as such, blood can now escape. And this is not ideal. What can happen therefore is this process called vascular spasm. A spasm means that an involuntary contraction of a muscle. What muscle in particular? The smooth muscle. So these are smooth muscles. Smooth muscles are found within the walls of the blood vessels. And when there is damage to the blood vessel wall, what happens is that the smooth muscles will contract, and this causes a constriction of the lumen of the blood vessel. Lumen meaning the hole of the blood vessel. As you can see over here, now the gap through which blood can flow through is much smaller, and now you expect that less blood will escape through the blood vessel. That's the first step to hemostasis. But vascular spasm alone is not enough to stop blood from escaping through our damaged blood vessels. As you can see, some blood will still escape. So we must find another way to plug the damage. And the second part of hemostasis is a process called platelet plug formation. Now, platelet is something that runs through your bloodstream. A plug, we're going to form a plug at the end of the day. Platelet plug formation. Now, as you can see in this diagram over here, I have a lot of other small particles apart from the red blood cell. Over here, you find that there are these small little particles called platelets. Platelets are essentially membrane-bound fragments of cytoplasm that flows through the bloodstream. Now, when a part of the blood vessel is damaged, as you can see this blood vessel over here, there is a damaged portion. When a portion of the blood vessel is damaged, what will happen is that signals will be released in the form of chemicals, and this activates the platelets to do something. What do the platelets do? The platelets will then travel to the site where the damage has occurred. It will adhere to the damaged site, but not only adhere, it will start to change shape. Originally you saw that I drew it in this shape. It changes shape so that it can become more sticky and stick to each other, and also the damaged site. As you can see, I've already gone ahead to draw all the other platelets that have changed shape and have adhered to the damaged site. This over here is what we call a platelet plug. It's quite intuitive because these are our platelets and this is a plug. This is the second step to hemostasis. But the final step, we're going to look at how we can reinforce this platelet plug. Because at the end of the day, this platelet plug is not a very strong structure, it's not very sturdy, it can break and more blood can escape. So in this final step of hemostasis, this is what's going to happen. We call this process blood clotting. I'm sure all of you have heard this process before, but I'm going to introduce a new term to you, or coagulation, which also means blood clotting. Now, what happens during blood clotting is quite interesting. We know that the platelet plug is not a very sturdy structure, so let's make it more sturdy, let's reinforce and make it stronger. But here I have something called a protein that's called fibrinogen. Now fibrinogen is a protein that is soluble. You see there are drawn green squiggly lines all over the bloodstream. It exists, but it's soluble as of now. What happens is that I can convert this soluble fibrinogen into an insoluble fibrin thread. So now it becomes a insoluble fibrin. This insoluble fibrin thread can then go on ahead to form something like a meshwork. Here I'm adding in the fibrin threads. What these fibrin threads are doing, they are forming a meshwork that further reinforces the platelet plug to prevent more blood from escaping. This is just the simplified process I'm describing, but to achieve this process of converting the soluble fibrinogen to insoluble fibrin requires a cascade of chemical reactions. Cascade just means a series of chemical reactions. So let me elaborate this series of chemical reactions. When there are damaged cells of the blood vessels, what will happen is that the damaged cells will secrete, or release, it will release certain substances that we call blood clotting factors. There are a variety of blood clotting factors, but the key idea here is that these blood clotting factors, they will come together to form something called a prothrombin activator. A prothrombin activator. And as the name suggests, activator, as the name suggests, it activates prothrombin. So the next step of the chemical reaction is going to activate something called thrombin. Here I have a prothrombin molecule. What happens is that prothrombin activator will go on to activate prothrombin. This is prothrombin, which is inactive at the moment. Now with the help of these prothrombin activators, it will convert it to its active form, which we now call thrombin. And this active form may look slightly a different shape now. This active form of thrombin will then go on to convert soluble fibrinogen to insoluble fibrin, which is what we were describing earlier. And this insoluble fibrin will then form a meshwork and that will reinforce the platelet plug. And not only does it reinforce the platelet plug, make it stronger, it may also trap some red blood cells along the way. And this makes this blood clot a lot more sturdy to prevent blood cells from escaping. So in summary, there are three processes that we hope you've learned through this short video that achieves hemostasis. Number one, and that is vascular spasm, where the smooth muscles of the blood vessel walls would contract to constrict the lumen to prevent more blood cells to escape. Number two is that of platelet plug formation, where we attract activated platelets which change shape and stick to each other to form a platelet plug. And number three, which is blood clotting or coagulation. This process involves the conversion of soluble fibrinogen to insoluble fibrin, which will form a meshwork to reinforce the platelet plug. But to achieve this requires a cascade of chemical reactions through the process. And that's the story of how my wound stopped bleeding at the end of the day, and I hope you've learned something out of this video.